Alright, so I'm sorry that the algebra worked out a little bit gnarly here, but you probably expected that to a certain extent. So anyway, what you found is a similar trick on 7 and 8, right? That you have this big ugly fraction that you plugged in, you canceled the x cubes here, you canceled the h after you factored it out. And then once you took the limit as h goes to 0, every term except the first term was just 0. So what you found is that if your function is x cubed, your derivative function is 3x squared. On the next one, the exact same thing happened, right? The x to the 4th is canceled. Everything else, when you plug in 0, it just goes 0. The derivative of x to the 4 is 4x cubed. So I'm hoping that when you look at these answers, 6, 7, and 8, you recognize, right? X squared, that 2 kind of came down and turned into a 2x. When you had x cubed, that 3 kind of came down in front, turned into an x squared. When you had x to the 4, that 4 kind of came down and became a 4x cubed. So when you have to take the derivative of anything in the form x to the n, it turns out that n is going to come down. So you're going to get nx to the n minus 1. So basically you're going to subtract, so you bring the power down and you subtract 1 from the power. And hopefully you came up with this on your own. If not, no big deal. It's called the power rule, and that's something we're going to use extensively throughout this class, pretty much the rest of the year. And it's a very powerful rule. Okay, and you can use this on all sorts of things, right? Because when you take the derivative of x to the 10, you just bring the 10 down in front, and you have 10x to the 9. You do not need to use that whole limit thing. You found the pattern using the limits, great, just use this shortcut. For something like B or C, you want to write these in the form x to the n. So before you take a derivative, write this in the form x to the 1/2. And then you're going to use this pattern that you came up with in number 9. So the derivative there, the 1/2 comes down, is 1/2 x to the negative 1/2. Here you write this as x to the negative 2. The negative 2 comes down. So the negative 2x subtract 1 to the negative 3. Okay, so that's how we're going to take the derivative as something that's in the form x to the n. Very powerful stuff, guys, and I think we're going to use this a lot. So on your homework and everything, that's what you're going to use. When you're taking derivatives, you're not going to do the limit unless it specifically tells you to. Okay, one more thing I wanted to share, just one thing about slope. So again, that was a key result. The derivative of x to the n is nx to the n minus 1. For any value of n, if this is your f of x, your derivative function is nx to the n minus 1. And again, that's an equation for the slope of your curve, the slope of the tangent line at any point. One thing I also want to talk about briefly, speaking of slope, the slope of the graph at an x value is f prime of x. So if I give you like some big graph that looks like that, okay, and say it looks like that, I don't know, like something like that, whatever, it doesn't matter. What I was saying is at this point, say at x equals 1, if you have a flat tangent line like that, f prime of 1 is 0. You have a horizontal tangent line, the slope is 0. Over here, say at, I don't know, like 3, you have a negative slope. So it may not be easy to see without doing a rise over run. I mean, you could do a rise over run and estimate, but I should not have put a dot there. Oopsie. But if I try and find the slope there, that f prime of 3, that is a negative value, right? Your function is sloping downwards. If you look over here, say, I don't know, at negative 3, and you find the tangent line there, it has a positive slope. So because you have a positive slope, your f prime of negative 3 is some positive number. And without an equation or a better graph, it'd be hard to figure out what. But just the idea of 0 versus positive versus negative, looking at the slope, that's important. Okay, some key ideas today. I hope this helped, and I look forward to helping you guys soon.